Hey guys, welcome back to another video. Today we'll be building a virtual paint app using Python. This app will track your hand using MediaPipe and then draw onto a blank canvas using your index finger. You can change the colors, erase, and even save the drawing all within one app. So without any further ado, let's get started. Before we begin coding this app, we need to install a few modules. So in your terminal, go ahead and say pip install OpenCV Python. Next, we're going to say pip install MediaPipe. And finally, we're going to say pip install NumPy and hit enter. And you should have them in no time. Now that we have what we need, let's go and write some code. We're going to start by importing CV2. We're going to use OpenCV for capturing video feed and also the drawing. Next, we're going to import NumPy as NP. We're going to use NumPy for handling arrays. Then we're going to import MediaPipe as MP. Now we're going to use MediaPipe for hand tracking, and finally we're going to import OS. OS allows us to save our drawings to files. Next, we're going to initialize MediaPipe's hand detection. So we're going to create a variable called MP hands, and I'll set it to MP solutions hands. So MP solutions hands is MediaPipe's pre-built hand tracking solution. By assigning it to the variable MP hands, we're just creating a shorter reference. So you don't need to type out the long name every time. Then we're going to create another variable called hands and set it to MP hands, hands maximum number of hands 1 and maximum detection confidence 0,7. This initializes the hand tracking system. Number of hands equals 1 only tracks one hand at a time instead of multiple. Minimum detection confidence equals 0,7 means the module must be at least 70% sure that it sees a hand before it counts it as a detection. This helps reduce false positives. Next, we'll create one more variable called MP draw and I set it to MP solutions draw utils. So MediaPipe provides a drawing utils helper that makes it easier to draw hand landmarks like fingertips, joints, and connections directly on the video frame. By assigning it to the variable MP draw, we can quickly call its functions later. Then we're going to create another variable called cap and set it to CV2 video capture. In this parentheses, we're going to have 0. Over here, we're opening our webcam. The 0 here refers to the default webcam. This will give us a live video feed to track our hand and draw. You can change this 0 to something like 1 if you want to use your external webcam. Next, we're going to create a canvas for the drawing. To do that, we're going to create a variable called canvas and we'll set it to none. This will eventually be the black screen where the drawing happens. Now we're going to create the color palette and labels. So I'm going to start by creating a variable called palette, set it to list. In this list, we're going to have our list of colors list in BGR format because OpenCV uses blue, green, red instead of the usual RGB. So we're going to say 22500, which is going to be the color blue. Then for the next one, we're going to have 02250, which is green. Then 00255, which is going to be red. After that, we're going to have 0225225, which is going to be yellow. And finally, 000, which is black, and that's going to be our razor. Then we're going to create labels to help the user identify the colors. So we're going to create a variable called labels and set it to a list. And in that list, we're going to have those colors in the same order that we have them at the top, so that the names and the colors fall into place perfectly. So blue, green, yellow, red, and of course the eraser. Now we're going to create one more variable called color index and set it to 0. This keeps track of which color is currently selected. 0 means the first color in the palette, which by default is blue. Every time we select a new color with our finger, we update this index. Next, we're going to create another variable called brush thickness and I set it to 7. This defines how thick the paintbrush line will be when you draw on the canvas. A smaller number means thinner lines and a bigger number means thicker lines. Then we're going to create a variable called eraser thickness and I set it to 40. This sets the thickness of the eraser tool. Notice it's much larger than the brush size, 40 compared to 7, so that it's easier to erase the drawings quickly. Then we're going to create two more variables, preview X and preview Y, and I'm going to set them to 00. This will store the previous positions of the fingertip. So when you draw, the app connects your previous point to the current point with the line. Setting them to 00 at the start means that there is no previous point yet. And then we're going to have one more variable called save counter and I set it to 1. This is a counter for saving the drawings. Every time you press S, it saves the canvas drawing as drawing1.png and then drawing2.png and so on and so on. This way each drawing gets a unique file name so that they don't overwrite each other. Now we're going to start coding the engine of this app. We're going to start out by saying while true, and in this loop we're going to start an infinite loop so that the program keeps running continuously, capturing video until we quit. So in here, we're going to create variables called success and frame and set them to cap read. Cap read grabs the next frame from the webcam. Success is a boolean true or false that tells us if the frame was read correctly. Frame is the actual image coming from the camera. So basically inside the loop, we read the next frame from the webcam. The variable success tells us if it worked and frame holds the actual camera image. If not success, break. This line checks if the webcam failed to capture a frame. If it did, we break out of the loop and end the program. Next, we're going to create a variable called frame, and I set it to CV2 flip frame 1. CV2 flip flips the image. The 1 flips it horizontally like a mirror. Without this, if you raise your right hand, it looks like the left hand is moving on the screen. With a flip, the camera feels more natural, like you're looking in a mirror. Then when I create variables height, width, and channels, and I set them to frame shape. Every image is just a matrix of pixels. Shape gives us the dimensions of that matrix. H is the height of the frame, number of rows of pixels. W is the width of that frame, number of columns of pixels. And C is the number of color channels. For a normal image, this is blue, green, and red. Now we're going to initialize the canvas. So when I say if canvas is none, this checks if the canvas is still set to none. Remember, we set it earlier as the placeholder. The first time the loop runs, it will be none, so that the program knows it's time to create a canvas. After that, the canvas is no longer none, so that we don't have to recreate it every frame. Then we're going to create a variable called canvas, and I set it to 0 height width 3 D-type NP unit 8. So we're creating the canvas using NumPy zeros. This gives me a black image the same size as the camera frame, with the 3 color channels for RGB. This is where all the drawing will happen. Next, we're going to draw the color palette at the top of the window. So we're going to say for I in color, enumerate palette. Here we're looping through every color in the palette, keeping track of both the index number and the color itself. Then we're going to create a variable called xstart. Then we're going to set it to I times 100. Then we'll create another variable called xend, and we'll set it to I plus 1 times 100. These lines calculate the positions of each color box. Every box is 100 pixels wide, so they line up neatly across the top. CV2 rectangle frame xstart 0, xend 100 minus 1. This draws the actual colored rectangle on the frame. Xstart 0 means the top left corner of the box. Xend 100 means the bottom right corner, so each box is 100 pixels tall. Color means the fill color taken from the palette list. Minus 1 means fill the entire rectangle completely instead of just drawing the outline. CV2 puts frame labels I, xstart plus 10, 90, CV2 font Hershey simplex 0,6, 225 if not equals 4, else triple 202. Here's what this part does. CV2 put text writes the labels like blue, green, etc. inside each rectangle. Xstart plus 1090 is the position for the text, a little inside the box. CV2 font Hershey simplex is the font style. 0,6 is the font size. The color 225, 225, 225 is white for normal colors, and the 200 is a light gray text for the eraser because it's black, and white would be too harsh. And this 2 over here will be the thickness of the text. Now we're going to process the hand landmarks. To do that, we're going to start off by creating a variable called RGB and set it to CV2, CVT, color frame CV3, color BRG to RGB. So OpenCV reads the frames in BGR format, but MediaPipe expects RGB. CV2 CVT color converts the color format of the frame from BGR to RGB. This ensures that the hand detection model works correctly. Then we're going to create a variable called result and I'll set it to hand process RGB. The line passes the RGB frame to MediaPipe's hand tracker. MediaPipe then analyzes the image and tries to detect any hands and their landmarks. The result, a variable containing all the information about the hand detected, like fingertip position, joint coordinates, and connections. Next, we're going to say if result multi-hand landmarks. Here we check if MediaPipe detected any hands. If it didn't, we skip the drawing for this frame. For hand landmarks and result hand landmarks, for each hand detected, we loop through all the landmarks provided by MediaPipe. Then we're going to create a variable called lm_list and I'll set it to an empty list. Then we're going to say id lm in enumerate hand landmarks landmark. lm_list append int lm times width, int lm y times height. So over here, we're creating a list of landmark points. MediaPipe gives x and y values between 0 and 1, so we multiply them by the frame, width, and height and get the actual pixel positions. Now we're going to say index x and index y equals lm_list 8. So over here, we grab the landmarks number 8, which is the tip of the fingertips. This is the point that we're going to use to draw on the canvas. Next, we're going to code the part that actually handles the color selection and starting a new line. So we're going to say if index y is greater or equal to 100, this line checks if the fingertip is within the top 100 pixels of the frame. The colored palette is drawn in this region, so being here means that the user is trying to select a color instead of draw. Then we're going to create a variable called color index and set it to minimum index x divided by 100, length of palette minus 1. This line determines which color in the box the fingertip is hovering over. Since each box is 100 pixels wide, so index x divided by 100 gives us the box number. Minimum length palette minus 1 ensures that we don't go out of bounds if the fingertip is at the edge. Then we'll create a variable called previous x and previous y and set them to 0, 0. This line resets the previous fingertip coordinates, so basically it prevents the brush from drawing a line from the last drawing point when switching colors. Else, if previous x equals 0 and previous y equals 0, previous x, previous y equals index x and index y. Otherwise, if we're drawing, we check if this is the first point. If so, we set the previous coordinates to the current fingertip position so our line starts smoothly. Next, we're going to code the part that actually handles the drawing and erasing on the canvas. So we're going to start off by saying if 0 is greater or equal to color index is greater than length palette. So before drawing, we make sure that the color selected index is valid so we don't get any errors. If color index equals length palette minus 1, CV2 line canvas previous x, previous y, index x, index y, 000 eraser thickness, this checks if the eraser is selected. Then we draw a thick black line between the previous fingertip position and the current one, effectively erasing any drawing along that path. Else CV2 line canvas previous x, previous y, index x, index y, palette color index brush thickness. Otherwise, draw a colored line using the selected brush color. Palette color index gives us the color of the current brush. Brush thickness ensures that the line has the right width. Then we're going to say previous x, previous y equals index x and index y. This updates the previous coordinates to the current fingertip position. This ensures that the next line segment connects smoothly from the last point. Now we're going to code the part that draws the hand landmarks for visualization. So we're going to say mp draw landmarks frame hand marks, mp hands connections. Here we use MediaPipe's drawing utilities to overlay the hand landmarks and connections on the camera feed, so we can actually see the detected hand skeleton in real time. Else previous x, previous y equals 0, 0. If there is no hand detected, we reset the previous coordinates. This prevents unwanted lines from being drawn when the hand disappears from the frame. Next, we're going to combine the camera feed and the canvas to show a side by side. So we're going to create a variable called combined and set it to nph stack frame canvas. Here we're using NumPy's horizontal stack function, which places the camera feed and the drawing canvas side by side so that the user can see both the hand gestures and the final drawing at the same time. Here when I say CV2 I am show virtual paint combined. Here we display the combined image in a window called virtual paint, updating in real time as we draw. Now we're going to code the keyboard control section. So we're going to create a variable called key and I'll set it to CV2 wait key 1 and off. And what's going on over here is that CV2 wait key 1 waits 1 millisecond for a key press. If no key is pressed, it returns -1. And the end off ensures compatibility across systems, so we only keep 8 bits of the key code. So basically we're checking if any key is pressed on the keyboard, then we wait just 1 millisecond between frames to keep things smoothly. If key equals Q, break. If the user presses the letter Q, the loop breaks and the program ends. LF key equals S, save path equals OS join, CV2 in right save path canvas, print save drawing as end, we call the save path variable we created, save counter equals +1. What's going on over here is that if the user presses the letter S, the current drawing is saved as a PNG file in the project folder. Each file is numbered so we don't overwrite previous drawings. Now we're going to add cap release. This releases the webcam or video capture device. It also frees up the camera so that other apps can use it again. Without this, your camera might stay locked until you restart your entire computer. Finally, we're going to say CV2 destroy all windows. This line closes all CV2 windows that were opened with CV2 IM show. It also ensures that the program shuts down gracefully without leaving any windows hanging. And that's it. You're finished building your virtual paint app. Let's go ahead and run the program. And as you can see, it has opened the camera feed as well as a black window next to it, which is our canvas. And if you drag your index finger, it will draw onto that blank canvas. And if you want to select a different color, all you have to do is hover over that color you want to select to change the color. And if you want to erase, you do the same. And that's it for this one. If you enjoyed or found this video helpful in any way, shape or form, then consider leaving a like and subscribing. Turn on post notifications to be the first when I upload a new video. Please help me reach my goal of 10,000 subscribers by the end of the year. Also, I'm always looking to improve. If you have any constructive criticism or any questions, or you just want to say hi, then leave it in the comment section below. And until next time, thanks for watching. Peace.